Unit 1, Objective 2, Solving Absolute Value Inequalities. This is the Advanced Algebra 2 Quarter 1 Review Solutions Explanation. If we take a look here, what is the solution to the absolute value of x plus 4 less than 2? Just like when we were doing equations, you have to first isolate the absolute value. In this case, the absolute value is isolated. Now, what I suggest doing so that you can understand what's going on, this stuff inside the absolute value is less than 2 steps away from 0. So here, I'm going to do what we call draw a picture in math. Okay, so we're going to draw our picture of what this inequality means. So I've got my number line, and here I have 0. This stuff, this x plus 4, is less than 2 steps from 0. So that means it can go all the way up to, but not include 2, or it could go all the way down to, but not include, whoops, make that an open dot, negative 2. Now that I've drawn my picture of my problem, I can go ahead and rewrite it. So down here at negative 2, the stuff inside the absolute value is greater than negative 2. I can see that from my picture. And x plus 2 is less than 2. Remember that if I have something like this, it's and, because I can be less than the top and more than the bottom. If you have something that looks like this, then you are, and this is your center, you are more than that many steps away or greater than. So when you go out, you're greater than. When you're in between, you're less than. So when you're looking at the graph, it just makes it easier to say what's happening with the x plus 4 instead of memorizing a bunch of rules. Once you have it rewritten, simply solve each side of the inequality independently. So over here, I'm going to subtract 4 from both sides. Leaves me with x. Negative 2 minus 4 is negative 6. X is greater than negative 6. And I subtract 2 from both sides. X is less than negative 2. I can turn this around and make it sandwich mode, if you want to call it that, by saying the negative, if x is greater than negative 6, that means negative 6 is less than x. And x is less than negative 2. This is sandwich mode. If you wanted it in interval notation, you would have negative 6, comma, negative 2. Remember that you're using parentheses. Why parentheses? Because you come up to, but you don't equal these values. Over here, everything's written in an inequality. So I can select B. I'm simply showing you this. So in case on the test, it's written in interval notation. You're responsible for being able to understand either. For this one, for number 2, which represents the solution to the inequality below in interval notation? Okay, first off, notice that my absolute value is not isolated. So the first thing I must do is isolate. I've got to isolate the absolute value. To do that, I'm going to add 11 to both sides. So I have negative 3 times the quantity n minus 5 less than negative 27. Negative 38 plus 11 is negative 27. Then I'm going to divide both sides by negative 3. Again, remember from the first objective, we can't distribute into absolute values. So I divide and I get absolute value of n minus 5 is greater than 9. Why did I change my inequality? I reversed the inequality because I divided both sides by the same negative value. Now that I have isolated, I'm going to draw my picture. I have 0 right here. This n minus 5 stuff is more than 9 steps away from 0. So I go out here to 9. I can't be at 9, but I can be anything farther away. Then I come down to negative 9. Again, I can't stand on negative 9, but anything farther away from 0 would be okay. Now that I've drawn my picture, I'm going to rewrite the inequality. This stuff inside, the n minus 5, is right here, and then I write down the negative 9. How is n minus 5 related to negative 9? It's to the left, or less than negative 9. Since I can't stand down here and up here at the same time, this is an or inequality. So I write the word or. Then again, I have my n minus 5. How is it related to 9? It's to the right, or greater than 9. So I write that one. Now I'm going to solve each inequality independently. Over here, I add 5 to both sides, so n is less than negative 4. I have to have the word or. Then n minus 5 greater than 9, I add 4 to both sides, n is greater than 14. N less than negative 4 or n greater than 14 are my solutions. I look over here and it's all in interval notation. That's okay. I can graph my answer. If I graph my answer, okay, I make my number line. And again, you can just sketch this on a piece of paper, on scratch paper. You have negative 4 down here, and then you have your 14 up here. N is greater than 14, open dot, and you go to the right. N is less than negative 4, you've got an open dot, and you graph everything to the left. Now, if I keep going forever to the left, that's negative infinity. It doesn't stop. Because I can't put a value on that, it's going to be a parenthesis. And then it comes up to, but it doesn't include negative 4, so I have my negative 4, and I put my parenthesis. The symbol for or is the union. Then I come up here and I'm anything after 14. So again, I'm going to put my parenthesis. Keeps going forever to the right. Forever to the right is infinity. And then I'm going to put my closing parenthesis. You just put a comma between them. Which option over here matches up? D. Okay? D matches up. Negative infinity to negative 14 or 4 to infinity. Those are my values. Before we leave this real quick, if I wanted to graph this guy over here, oh, whoops, sorry about that. Let me make a more horizontal line. Okay, I could do this. I could put negative 6 here, and I could put negative 2 here, and the graph is anything in between. Notice the graph of the solution right here is the same shape as the graph of the problem. This, however, represents what x equals, okay? This up here is what x plus 4 is. All right, let's go on to the next two problems. This third problem says circle all the solutions to absolute value of 9x plus 3 less than or equal to 21. First, I notice that the absolute value is isolated. Great. Then I want to draw my picture. So the stuff inside here is less than 21 steps, less than or equal to 21 steps. So here's exactly 21 to the left. Here's exactly 21 to the right. And I am somewhere in between or on one of those 2 points. Now I can come along and say that 9x plus 3 is somewhere in between negative 21 and 21. So 9x plus 3, when I look at negative 21, it's to the right of it, so it's greater than or equal to. And I know that when I'm in between, I'm and. The 9x plus 3 is to the left of 21, so it's less than or equal to 21. Now that I have rewritten my absolute value inequality as a compound inequality, I'm going to solve it. I start on the left, I subtract 3 from both sides, and I have 9x greater than or equal to negative 24. I divide both sides by 9, and I get that x is greater than or equal to negative 24 over 9. I can simplify this. 3 will go into 24 and into 9 evenly, So I wind up with x greater than or equal to negative 8/3. I have to bring the word and down. The word is important. Then I have 9x plus 3 less than or equal to 21. I subtract 3 from both sides. So 9x is less than or equal to 18. Dividing both sides by 9 to get the x alone, I have x less than or equal to 18 divided by 9 is 2. I now have x less than or equal to 2. It's an and. I can go and rewrite this in sandwich mode. So I put the negative 8/3 is less than or equal to x is less than or equal to 2. Fantastic. I want to graph this. So I'm going to draw my graph. I'm not going to put a ton of little tick marks in. I'm just going to say I know negative 8/3 is my smallest value. And my biggest value is 2. Because it's equal, I'm going to use solid points. So I use solid dots. I'm more than negative 8/3, so I go to the right, and I'm less than 2, so I come down, I meet in the middle. Here's my graph. Boom, I can pick this one off. I know that it's in between. It can't be this guy. Then, because it's equal to, I know interval notation will make this a bracket. I start here, I go up to 2, because it's a solid point, I make a bracket. I have this answer. I know this can't be it. Finally, right here when I rewrote it in sandwich mode, I got this. I also know that it's an and, not an or. I have selected the 3 representations for the solution to my inequality. Next up, we have problem number 4. First things first, we have to isolate the absolute value. Get the absolute value alone. First up, add 5 to both sides. 2, absolute value of 4x plus 1 is less than 6. Now I'm going to divide both sides by 2. Then I'm going to draw my picture. So I have, here's 0. I'm less than 3 steps from 0. So I can go, starting at 0, I can go up 2, but not include 3. And then I can go down 2, but not include negative 3. I've got my picture. Now the stuff inside the absolute value, 4x plus 1, it's to the right of negative 3, so it's greater than negative 3. And I recognize the in-between is and. The 4x plus 1 is to the left of 3, so it's less than 3. So here is where I use my picture to help me rewrite my absolute value inequality as a compound inequality. Then I simply evaluate. So over here, I'm going to subtract 1 from both sides. 4x is now greater than negative 4. I divide both sides by positive 4, so x is greater than negative 1. I divided both sides by a positive, therefore I do not reverse the inequality. X is greater than negative 1. I have to bring my word and down. I divide both sides by 4. X is less than 2/4, and I think about it, I can reduce that to 1/2. So I've got x is greater than negative 1 and x is less than 1/2. I can rewrite this as negative 1 less than x. Notice it's still pointing to the negative 1, which is less than 1/2. I can graph it. Open dot on negative 1 and 1/2, and I'm in between. And then to put it in interval notation, because it's an open dot, I put an open parenthesis, a comma, and a parenthesis because it's also an open dot. So here is how I got my interval notation. Notice it asks you to write it in interval notation. Number 5, solve and graph. Again, step 1 is isolate. I need to get the absolute value by itself. So I divide both sides by -3. When I divide both sides by a negative, I have to reverse the inequality. When I reverse the inequality, okay, so you divided both by -3, you had to reverse the inequality. Now I have the absolute value is greater than -3. Well, absolute value is your distance from 0. So absolute value, any absolute value is always greater than or equal to 0. So if I'm saying that it's greater than -3, this will always be true, excuse me, which also means it's all real numbers. A number of ways to indicate that. Negative infinity to positive infinity. It wants it in interval notation, so you would put that. You could also put in set builder notation, x is an element of all real numbers. And for the graphing it on the number line, you could put any value you wanted here, 0, 5. Oops, I need to move my little recording guy. I'd have -5, and it just keeps going forever in both directions, negative infinity to positive infinity. Okay? So it's all real numbers. You had to reverse that inequality. That is Unit 1, Objective 2, Absolute Value Inequalities.